When the digital world falters, it often points to a stumble in the colossal cloud infrastructure that underpins much of our online lives. An AWS outage, though infrequent for its scale, serves as a powerful reminder of our deep digital dependency in the intricate dance of system resilience required to keep the internet humming. The unseen giants stumble. In an era where nearly every click, stream, and transaction relies on the internet, the underlying cloud infrastructure has become the invisible backbone of modern society. Amazon Web Services (AWS) stands as a titan in this domain, powering an immense percentage of the world's websites, applications, and digital services. From global e-commerce giants to emerging startups, government agencies, and even critical public services, countless entities entrust their core operations to AWS. This ubiquity means that when AWS experiences a service disruption, it's not just a minor glitch. It's an event with far-reaching consequences that can ripple across industries and impact millions of users simultaneously. An AWS outage isn't typically a complete global shutdown of all services. Such an event would be catastrophic beyond imagination. Instead, it usually manifests as a localized or service-specific disruption, often affecting a particular geographic region or a specific set of services within that region. However, due to the interconnected nature of modern applications, even a seemingly isolated issue can trigger a cascading effect. A problem with a core networking service, a database, or a compute platform can render countless dependent applications unusable, leading to widespread frustration and significant operational challenges for businesses worldwide. The very design principles that make AWS so powerful, its distributed architecture, vast scale, and complex interdependencies, also make it susceptible to intricate failure modes. While AWS invests heavily in redundancy and fault tolerance, no system, regardless of its sophistication, is entirely immune to unforeseen circumstances. These events underscore a fundamental truth in technology. Even the most robust and meticulously engineered systems can, and occasionally will, stumble. Understanding the anatomy of these disruptions is crucial for anyone operating within the cloud ecosystem. Anatomy of a cloud disruption. The causes behind an AWS outage are as varied and complex as the infrastructure itself. Often, they stem from a confluence of factors rather than a single point of failure. Human error, despite extensive safeguards, remains a significant contributor. A misconfigured network device, an accidental deletion of a critical resource, or an incorrect deployment can inadvertently trigger a chain reaction. Software bugs, whether in new code deployments or existing systems, can also lead to unexpected behavior and widespread service disruption. As AWS continuously innovates and updates its vast array of services, the potential for unforeseen interactions or latent defects to surface always exists. Hardware failures, though increasingly rare thanks to redundant components and proactive maintenance, can still play a role. A power surge in a data center, a faulty network switch, or a storage array malfunction can compromise the operational stability of a specific availability zone or even an entire region if not adequately isolated. Furthermore, network connectivity problems, such as issues with domain name system DNS resolution or border gateway protocol BGP routing, can prevent users and services from communicating effectively with AWS resources, even if the underlying compute and storage are functioning perfectly. AWS employs a multi-region and multi-availability zone Aws strategy to enhance system resilience. Each region is a distinct geographic area, and each Aws is an isolated location within a region, designed to be independent in terms of power, cooling, and networking. This architecture is intended to confine failures to a single AS, preventing them from affecting an entire region. However, in some rare instances, the scope of an outage can transcend these boundaries, highlighting the immense challenge of managing a global-scale distributed system. Pinpointing the exact root cause during an active incident is a race against time, requiring sophisticated telemetry and rapid diagnostic capabilities. The ripple effect, impact and consequences. The immediate impact of an AWS outage on businesses is often stark and immediate. Websites go dark, e-commerce platforms cease processing transactions, and critical business applications become inaccessible. For companies heavily reliant on AWS for their core operations, this translates directly into financial losses, lost sales, decreased productivity, and potential penalties for failing to meet service level agreements (SLAs). Beyond the monetary cost, there's the significant reputational damage. Customers lose trust, brand loyalty erodes, and the perception of reliability can be severely tarnished, taking considerable effort and time to rebuild. The broader societal implications of an AWS service disruption are increasingly profound due to our pervasive digital dependency. When AWS stumbles, it's not just tech companies that feel the pinch. Streaming services become unavailable. Online banking systems might falter. Communication platforms can experience delays. And even smart home devices can lose functionality. This widespread impact underscores how deeply intertwined AWS has become with the fabric of our daily lives, transforming what might once have been an IT issue into a public concern. The ripple effect can touch everything from entertainment to essential public services, making these events a matter of public interest and concern. The financial toll of an outage extends far beyond the immediate losses. Post-incident, companies often incur significant costs in recovery efforts, customer compensation, and investments in more resilient architectures. While AWS itself works tirelessly to restore services and conduct thorough root cause analyses (RCAs), the onus is also on its customers to design their applications with fault tolerance in mind. The sheer scale of AWS's customer base means that even a minor disruption can collectively cost billions across the global economy, making the pursuit of continuous operational stability a shared imperative. Lessons learned and proactive measures. Given the inevitability of occasional disruptions, businesses operating on AWS must adopt proactive strategies to mitigate the impact of an outage. The cornerstone of such a strategy is system resilience. Designing applications to be highly available across multiple availability zones within a region is a fundamental first step. This involves distributing resources, replicating data, and configuring load balancers to automatically route traffic away from impaired zones. For the most critical applications, a multi-region strategy, though more complex and costly, offers an even higher degree of protection against widespread regional failures. Robust monitoring and alerting systems are equally vital. Companies need comprehensive visibility into the health and performance of their AWS resources, with automated alerts configured to notify teams at the first sign of trouble. This allows for rapid detection and response, minimizing the duration and impact of any service disruption. Furthermore, a well-defined backup and recovery strategy is non-negotiable. Regular, automated backups of data and configurations, coupled with thoroughly tested recovery plans, ensure that even in the event of data loss or corruption, systems can be restored quickly and efficiently. Effective communication during an incident is paramount. Both internal teams and external stakeholders need clear, timely updates. AWS provides its own service health dashboard and status pages, which are critical resources for customers to track the status of services. However, businesses must also have their own communication protocols in place to inform their users and customers transparently, manage expectations, and maintain trust. These proactive measures, while requiring investment, are essential safeguards against the profound consequences of an unexpected AWS outage. The future of cloud reliability. AWS, like any leading technology provider, is in a perpetual state of evolution, constantly investing in its cloud infrastructure to enhance reliability and performance. This includes deploying new hardware, refining operational procedures, and developing more sophisticated fault detection and self-healing mechanisms following every significant service disruption. AWS conducts an exhaustive root cause analysis (RCA), publishing detailed reports that not only explain what went wrong but also outline the preventative measures being implemented. This commitment to transparency and continuous improvement is a cornerstone of maintaining trust. With its vast customer base, the evolving landscape of cloud computing also offers new avenues for improving system resilience. Architectures such as serverless computing and containerization, by their very nature, can help isolate failures and distribute workloads more effectively, reducing the blast radius of any single component failure. Edge computing, which brings compute resources closer to the data source, can also reduce reliance on central regions for certain types of applications, potentially mitigating the impact of regional outages. These advancements contribute to a more robust and adaptable cloud ecosystem, ultimately achieving 100% uptime in a system as vast and complex as AWS remains an elusive goal. The inherent trade-offs between complexity, cost, and absolute reliability mean that occasional disruptions are an inevitable part of operating at this scale. However, the continuous pursuit of higher operational stability and fault tolerance drives innovation across the industry. While an AWS outage can be a frustrating and costly experience, it also serves as a powerful catalyst, pushing both cloud providers and their customers to design, build, and operate more resilient digital systems. Beyond the immediate fix, the impact of an AWS outage extends beyond the technical and financial. It also has a significant psychological toll on the engineers and businesses scrambling to respond. The pressure to restore services quickly, communicate effectively, and learn from the incident can be immense. This highlights the importance of robust incident management frameworks, not just for technical resolution but also for supporting human teams under stress. The practice of chaos engineering, where engineers intentionally inject failures into systems to test their resilience, is becoming an increasingly valuable tool in proactively identifying weaknesses before they manifest as real-world outages. The relationship between cloud providers like AWS and their customers is symbiotic. While AWS provides the foundational cloud infrastructure, customers bear the responsibility of designing their applications to leverage the platform's fault tolerance features effectively. This ongoing partnership in building and maintaining resilient systems is crucial for the continued growth and reliability of the digital economy. Every AWS outage, while disruptive, ultimately contributes to a deeper understanding of distributed systems and fuels the drive for greater system resilience across the entire cloud landscape. Reflecting on the nature and impact of these events, it becomes clear that our shared digital dependency on such foundational services is both a testament to their power and a source of vulnerability. How prepared do you feel your own digital footprint is for the next major cloud event? And what steps do you believe are most critical for fostering greater collective operational stability in our increasingly interconnected world?